Alright class, we're going to do a little review for points, lines, and planes to make sure that we understand everything that's happening. I gave you this review packet. You already have the answers, but I'm going to work through these things so we can see it come to life here. Number one, give three other names for line CB. Here's line CB. Remember, lines go on forever? I need to find three other names. I need 2 points to name a line. So I could name this line CG. That's 2 points right here. And that line goes on forever, so it's still the same thing as CB. I could name it line BG. And I could also name it line M. Now there may be other ways, and there are other ways, but that's 3 ways that we could use to name line CB differently. Write another name for line P. All we need is 2 points to name a line, and we start with our line symbol on top, and we're going to pick 2 points that are on line P. Here's line P. This is an arrow in case you guys can't make that out. I could call it line CD. There are other names. We could have used CA, DA, line AD, line AC, and I think that's everything, but there may be more out there. What points do or does line AB and line M have in common? So first let's find line AB. Here's line AB, and then line M. Well, what point or points do they have in common? If 2 lines intersect, they only have 1 point in common. So their point in common is point B. List all points which lie on line L. And here's line L. We'll clarify really quick. Line L, all the points that lie on line L. Now we can know that there's an infinite number of points on line L. However, if we're using the figure shown, we're only going to worry about the shown points. So the points on line L are A, E, and B. Those 3 points. Again, there's an infinite number of points. We could never list them all. But if we're using the given figure only, we have points A, E, and B. So if I look at the number 5, write 3 other names for line AC. Well, let's look at where line AC is. It's right here. Line AC goes on forever. It also has another name, line P, but we've already used that one, so let's go through some other names. We could call it line AD. Remember, we could switch those letters, and it's still the name of the same line. Those points, line DA, and then let's also call it line A. Oh, we already used AC, that's what it gave us. Line CD. Alright. Now let's go on to the next group. Use the given figure again. We're just going to look at what it gives us in the figure only, even though we know that there are more, like on every line there's an infinite number of points, on every plane there's an infinite number of points. How many lines contain the point B? We know that there are an infinite number of lines that contain the point B. Through any line, I can make an infinite, or correction, through any point, I can make an infinite number of lines over and over again. All these lines can go on forever and still go through this point. But if I'm using only the figure that I have here, how many lines contain point B? There's 1 right here, line FB. So using only the figure, we would say that there is 1 line containing point B. But if we wanted to go beyond the figure, beyond the scope of the figure, there are an infinite number of lines that do contain point B. So how many lines contain both point A and B? Well, through any 2 points, there is 1 and only 1 line. So there is only 1 line that contains both A and B. Okay? is line AC contained in plane K? We need to identify and find plane K really quick. Here's this K. It's identifying this plane. And is the line AC contained in plane K? We don't show you that line, but let's go ahead and draw it in here really quick. It would go, well, if I could actually draw from A through. All right, folks. Now I'm going to cheat. It would go that's not what I want either. All right, here we go. There we go, finally got it. All right, and it would go on forever in both directions, but if it goes through both A and C, it is also going to be contained in the plane K, because points A and C are on line K, or on plane K. The line that goes between them is also on line K, or plane K. So yes, it is, line AC is contained in plane K. Name the intersection of planes E and K. So here's plane E. We see the letter here. Where's the intersection? Now be careful. It is easy to think that the intersection of planes E and K is FB, and that would not be totally false. We could write FB, but what is FB? Remember, these planes extend forever in these directions, so the actual figure is not a line segment or 2 points, but a line that will go along forever the intersection of these planes. List 3 points which determine plane K. Remember, to name a plane, we need to have 3 non-collinear points. So as long as I choose 3 non-collinear points, all contained in plane K, we could name it that way. I'll choose point D, point B, and point C. We can name it plane DBC. We can name it a number of other things as well. Name 2 points which determine line M. So for line M, let me get this line on out of here. Line M, I need 2 points that lie on line M to name it. Points A and G are on line M. I could name this line AG as well. Is there any point on line AC that is not on plane K? Well, no, we just identified in number 8 that line AC is contained in plane K. And if something is contained in a plane, it means that every point in that figure is also on the plane. So that would be a big no. For exercises 11 to 13, use the diagram to determine whether the statements are true or false. So here it's a cube, all right? So we have a cube. Every cube has a plane has a square face, and every intersection is a 90-degree angle. So we have square faces, 90-degree angles. Points A, B, and C are collinear. Are points A, B, and C collinear? No, they do not all lie on the same line. They are on 2 different lines, so that would be no, false rather. That would be false. Points A, B, and C are coplanar. Yes, they are. We don't even have to look at the figure to see that points A, B, and C are coplanar, because remember, any 3 points are coplanar. If you have only 3 points, they're always coplanar. Points A, B, G, and H are coplanar. Now, instinct might tell you, your initial intuition might say that's false. But when we take a look at this figure, there is a plane that passes through these 4 points. I could lay a slant plane, basically, going along a diagonal through this box, and I could capture points A, B, G, and H. So that is true. Now, AE and BF are coplanar. they're a little lazy here. We need to put some segment marks on top of here. Segment AE and segment, and I'll get rid of this marking that I just put on there. Segment AE and segment BF are coplanar. Yes. On this face of the cube, it's representative of a plane that continues on forever. Segment AB and segment BF are both coplanar. That's true. Segment DC here and segment FG are coplanar. That is not true because DC and FG do not intersect. They are not parallel. They're skew. They are not coplanar. DC and FG, we could not draw one plane and capture both of them completely. For exercise 18 to 20, refer to the diagram. Name the intersection of the planes. Plane PQR, all right, and plane QRU. So we have this plane represented by the triangle here, and plane QRU by the back face here of the object. What is the intersection of this plane PQR and QRU? Their shared points are along line QR. And remember, if these are planes, they extend forever. So segment QR is not the only figure that is on the intersection of the planes. Not just segment QR, but line QR. As the planes go on forever, we need an intersection that goes on forever, so we need to use a line. Plane PQR and plane STU. Plane PQR and plane STU. Alright, if we look at these two planes, we have a 90-degree symbol here. There's a 90 degrees over here, not shown very well in this printout. There's a 90-degree symbol there. So these planes don't intersect. They are parallel. There is no intersection there between those two planes. Now let's look at, they use 4 letters. We're only going to use 3. Plane PQT, which goes over to this corner. Our T is hiding right there. Plane PQT and plane QRU. So we're talking about plane PQT represented by the bottom here and plane QRU as the back. So the intersection would be line, not line segment, QT. Line QT. All right. Let's finish up with a little sometimes, always, or never. If something is always something, then it always is. There's never a time where it's not. And if something is ever not something just one time, it makes it sometimes correct. And if something never happens, it's never. So always, always, never, never, sometimes, sometimes. 3 points determine a plane. That is and when we say determine a plane, we mean, can we name a plane with 3 points? Well, we can name a plane with 3 points unless those 3 points are collinear. So, do 3 points determine, or can we name a plane with 3 points? Yes, but can we always name it with 3 points? No, not any 3 points. So, sometimes we can determine a plane with 3 points. In the event that they're collinear, those 3 points do not determine a plane. If 2 points are contained on a plane, then the line that passes through those points is blank contained on the plane. If 2 points are contained on a plane, we'll represent a plane here, and 2 points, then the line that passes through those 2 points is always contained on the plane. A point is blank contained by infinite number of lines. A point is always contained by an infinite number of lines. I can draw any number of lines through any point. It is always contained by an infinite number of lines. 4 points are blank coplanar. Well, let's take a look at that. 4 points can be coplanar. Here's my plane. 1, 2, 3, 4. Those 4 points are all contained in the plane. But what if I take one of those points and I remove it from this plane and I put it above the plane? Now the 4 points are not coplanar. Remember, any 3 points are coplanar, but 4 points are only sometimes coplanar. And then 3 points are blank collinear. Again, if I have any 2 points, I can draw a line through them. They are always collinear. But if I add that third point to talk about, now I can't draw a single line and capture all 3. I could draw 3 lines in a row and have them be collinear, but I could have a third line not collinear. So again, this is a sometimes. And collinear points are coplanar. If points are on the same line, then I could definitely contain them in a single plane. In fact, multiple planes. So this one is always. Hopefully the review has helped you guys out a little bit. Please ask questions in class if you still have questions, and make sure you look through and try some other problems on your own. Try to make sure you understand and have a dictionary of terms and notations so you're ready for the quizzes and tests that we have coming up.